So next I'm going to talk about the past, present, and future of AI, its history and some of its key milestones and some recent developments. So we'll we'll dive into some of the timelines that to characterize AI. So in 1950, Alan Turing proposes the Turing test. That's now become famous in AI circles. So basically, what does it mean to be human? A Turing test is, if I can, for example, have a conversation behind a hidden screen and I can't tell the difference between am I talking to a person or am I talking to an AI machine, we say that that thing has passed the Turing test. By the way, we've kind of moved beyond that. Things can pass the Turing test already. In 1956, John McCarthy coins the term artificial intelligence for the Dartmouth College Summer AI Conference. So artificial intelligence wasn't a term until it got coined, right, by John McCarthy. In the 1960s, Ray Solomonov uses Bayesian methods. So remember, I mentioned, really key statistical thing was called Bayesian statistics. So its key thing is that through prior knowledge of something, so prior probabilities, I can anticipate, I can deduce, I can infer the chance of a future thing happening. Really crucial concept. In 1965, Alexei Ivanenkov makes the first deep learning multi-layer perceptron. So again, we're moving towards how do we make an AI, right? Like, well, maybe neurons is the way to go. Now we have one of the first three AI winters. So there was a tremendous amount of expectation, a tremendous amount of hype, and coming out of World War II, there's a strong sense and a really positive outlook on technology, on really advanced technology. Think like the Jetsons, right? The jet age. We're doing some incredible things with technology spurred from developments of World War II. We've been able to split the atom. We have nuclear power. There was a really general, very optimistic view of technology at that point, and maybe too optimistic, right? So computers hadn't quite caught up with AI, and people poured lots of money into it, had lots of hype, lots of expectation, but it didn't meet those. So people's enthusiasm cooled down. And those are called AI winters. And that first was from 1974 to 1980. In 1985, though, in the 80s, backpropagation algorithms spurred a resurgence in machine learning. Those are used to iteratively train a neural network through gradually minimizing errors. So backpropagation, really just fancy words for using feedback, right? So we use feedback all the time. When you when you talk to somebody, when you walk across a room, in order to, how did you do? How you use feedback to figure out how well you did something. We encounter another second AI winter. Again, too much expectations on AI. But however, in the 90s, the PC revolution hits, and computers are now starting to double in power of 18 months from Gordon Moore's law. And computer capabilities are starting to catch up with expectations slowly, and every 18-month chunk, every doubling. It doesn't take that many doublings before computer power is pretty amazing. In the mid-1990s, we shift from knowledge-driven to a data-driven approach, and that's still with us today. So support vector machines or current neural networks become popular. And earlier I said, it's really lowercase a, lowercase I, and big M and big L. It's really data mining, using and doing what computers do best, and that's crunching lots and lots of numbers and data. And in the LLM model, it's taking lots of data, crunching it, and that's why there's this shift to a data approach, because the computers are catching up to the point where that's a very viable thing to do. And in 1997, Deep Blue, a chess machine, defeats the then world champion Garry Kasparov using symbolic AI to represent chess. In 2002, the iRobot's Roomba is an autonomous robot that vacuums the floor while navigating and avoiding obstacles, and it heralds the domestic use of AI in robots. And I'll say, the home environment is a very complex and very difficult environment to navigate for AI to be in, right? So, if you look at Alexa and Amazon and Echo, I mean, those are basically just cylinders. It doesn't have to navigate around you or a baby or a dog or a cat. It just sits on the desk. So Yeah, but the Roomba is pretty amazing because it does do that. It has to it has to navigate around chairs and tables and things that can move in front of it, a baby or a cat or a dog. So and not damage them, right? Not harm them, and yet have the goal of cleaning the floor. So it's pretty amazing. But notice that it looks nothing like the sci-fi robot, right? It doesn't look like Rosie the Jet from the Jetsons, right? In 2005, Honda's Asimo robot, and I encourage you to look videos now today, of course, there's incredible videos of robots doing some amazing things. But remember, 20 years ago, Asimo was doing some amazing things. It could walk upstairs and walk downstairs, and deliver trays to customers in restaurant settings. It was doing some pretty incredible things 20 years ago. 2010, deep learning and machine learning become integral to many software services and applications, and we've talked about this a lot already. 2011, Amazon introduces Echo, a voice-controlled intelligent personal assistant. 2018, Hiroshi Ishiguro creates Erica, the world's first robotic humanoid news anchor in Japan. OpenAI introduces GPT-3, an autoregressive large language model using deep learning. And in 2023, ChatGPT reaches 100 million users, making it the largest consumer application. ChatGPT 4 scores really high on various tests. And in 2023, the self-driving cars go commercial, Waymo and Zoox. So I've been giving these lectures here at Drexel University for a number of years before 2023, and my previous lectures had talked about self-driving cars and some of the theory behind them. And in October of 2023, I actually sat in a a Waymo, it's really quite a really neat experience. And then this year, my neighbors got a self-driving car, a Tesla Model Y. Um, so some of the things that we're seeing, and there's so much things. There's so many things happening. I have to kind of pick and choose some key things. So autonomous AI agents I talked about, multimodal generative AI, human-centric and explainable AI. You hear a lot about that in this course. 5G massive machine type communications and the Internet of Things. Um, what's called immersive communications, virtual reality, augmented reality, mixed reality, and extended reality. These are things that will be that to some degree is here, but will be much more prevalent in the upcoming years. So, and AI enhanced creativity. So it's always hard to prognosticate into the future. These numbers I got from like some experts, quote unquote, in the field, and you have to totally take these with a grain of salt. They may be much sooner, they may be much later. But we have here, certainly, I don't think anybody will disagree. We have enhanced narrow AI that's capable of performing some kind of task like a ChatGPT, and AI-initiated operations, things like making software, AI that can write software. We kind of already have that. I have friends who are software developers, and it's pretty amazing the impact that software writing AI has already. But there's also things like low code and no code things, and Python is actually quite easy to learn. I've learned many computer languages in my life, and Python was by far the easiest computer language I've learned. Mathematical solutions, research papers initiated by AI programs. So we're not quite here for some of these things, but we're getting there. And then, of course, artificial and general intelligence, which I've already talked about, AI with full cognitive capabilities mimicking a human. And then super intelligence, AI with cognitive capabilities beyond a human. So this first bottom of the pyramid, things that that are user-driven and use big data models for machine learning, training and ad hoc models and custom learning, and then cognitive self-learning. So we're climbing up this pyramid, and in various ways and in different aspects and not at the same speed. But as you can see from Agentic AI, there are tendrils climbing up this pyramid. Okay, next I'm going to talk about how is AI/ML used? What are some of its practical applications? I kind of touched on some of them, but I'm going to spend some time talking about that more now. Like, why does all this matter to society? Why does this matter to you? So some examples of unsupervised learning in the a priori association method. Some examples are like sales functions or word associations, searching through a book, let's say. K-means clustering can be used to performance monitoring. How well is something doing? Or searcher intent. um, Artificial neural networks have been used for a lot of things, but to generate new and synthesize data, a lot to pattern recognize and data mine. Linear regression is good at sales forecasting or risk assessment to important tasks for, say, for example, the assurance industry. Support vector machines can be used for any sort of thing you need to classify. It falls on one side of the hyperplane or other. And so looking at financial performance comparison, anytime I need to compare something, right? That's when it's good for. And there's lots of things we can compare things for, right? Decision tree classifications is good for predictive analytics. So when I want to predict something or how to price something. And then we get to the more advanced methods of ML. So like the GAN, general adversarial networks, that's good for audio and video manipulation, data creation. The self-training naive Bayes classifier is good for like natural language processing. And here we get to the reinforcement. The most complex models are good at like linear tasks, estimating parameters, having something run through a maze, complex things like that, policy creation, consumption reduction. And then even more just sort of practical things. It'll hit, I think, just about every industry, and it's already basically hitting most of these industries, right? So the aerospace to hospitality to real estate, you can think of, and if you haven't already seen AML touch on these industries, you are likely to eventually. But the things that are data centric, they're data heavy, are the ones that are going to get the most impact, the most revolution, the most um, oomph, the most bang for their buck, and will hit AIML will hit first, right? So things like finance, it's all about numbers. In the legal area where you're processing tons of legal documents, right, in discovery. Self-driving cars, it has to a lot of data figuring out how to get from point A to point B or interpreting the road. We'll talk about smart cities in a second. um, Starting to hit on entertainment, intelligent personal assistants, the AI agents and agentic AI. This is a chatbot applied to your personal life, basically, or a set of chatbots applied to your personal life. And we'll talk about smart homes in a second. So homes right now, we've already seen how like Ring, those automatic doorbells and smart lighting. So already lots of um, there there are a lot of, since I created this slide many years ago, there are now many products in many of these areas already, and if there aren't, you will see more of them. So smart door locks exist already, AML-driven security. Now, some of these things aren't necessarily sort of AIML yet. They're not smart, quote unquote, but there are smart lighting control systems, smart thermostats, some smart appliance control. And some of these are in various stages of development. Some things are still kind of pre-AI ML. But the first step is to connect it to something, right? So there's more of a kind of wireless association first. And then once you get to that point, then you can have applications that are more advanced and are smarter. Likewise, we'll see smart cities for emergency service, power management, disaster recovery, public safety, transportation, self-parking, augmented reality. So imagine like you're walking through the city and it can overlay information. Oh, you just came across a historical site, or this is of significant historically building that was of a building of historical significance. Connected car service, sanitation management, transport analytics, water management. So smart intersections that can collect traffic data and just lights, parking apps, solar panels to improve city energy management, smart street lights, trash cans, emergency departments, and bus stops. So we'll see all of these things in the coming age of AI. I put together this slide to kind of summarize the stages of industry, and we're in Industry 4.0 now. And you will see also, or have already heard of, Industry 5.0. So we're already kind of into Industry 4.0, and people are already talking about Industry 5.0. But Industry 1.0, people more commonly refer to that as the Industrial Revolution, right? So Industry 1.0 now, it was retro named the Industry 1.0, but it's really the Industrial Revolution. It happened from 1750 to 1850, and it really shifted us from cottage industry, small scale production of people just making stuff in their and handcrafted goods. So basically, when farmers in the winter didn't have anything to do, well, they made stuff, right? And that was those cottage industries, and they moved from factory systems to large scale production, mass produced goods, and the first really revolutionary factory system was the textile industry. Now, this happened first in England, and it's really interesting to study why it happened in England and not in other places. It eventually caught on to other places, but it really took off in England first. So the study of, I won't go into that now, but I leave it to you as a homework assignment to figure out. It's a fascinating story. So Industry 2.0, though, happened in the U.S. from 1870 to 1930. Um, it was really for the Model T, the creation of the assembly line, mechanized industry, interchangeable parts, but also the electrification of factories made a huge social difference in society when it was merged with the concept of mass production. And it was what's called the American system. So we invented the middle class, we invented mass consumerism as a result. Industry 3.0, starting from the 1970s, was really marked by the introduction of computers and automation into the factory, into industry. So electronics, technology, electronics, and programmable logic controllers really spawned precision manufacturing with limited human intervention. And we're still riding on that tidal wave. And Industry 4.0 is really characterized by AI/ML and networks that will produce smart factories. So we're at the start of really, I think, kind of at the start of Industry 4.0. I mean, we have yet to really realize 5G, all the key principles of 5G, enhanced mobile broadband, eMBB, URLLC, ultra reliable low latency communications, sub-millisecond latency, and MMTC, massive machine type communications. Those are the three things that characterize 5G. So we haven't really realized all of that yet. And we're talking about 6G. I'm at my work, I'm designing 6G, right? And but these waves overlap, right? Of course, we're still realizing the full possible potential of computers and automation in factories. And we're only just at the start of this, I feel, the Internet of Things. So the Internet of Things is really designed for trillions of devices. A person right now has maybe 1, 2 devices that are connected. 5G is designed for 1 million devices per square kilometer. That's one device per 0.92 square feet. That's that's when you have 10 devices per person, right? That's what 5G is designed for. So we're not quite there yet, but we can see how that will totally transform the factory and industry into smart factories. Okay, I had a target this year to read 100 books. I'm on my 99th nonfiction book this year, so I'm gonna be able to make it. I wasn't sure that was possible. It does take a lot of time to read a lot of books. But one of the more interesting books I read this year was called Unit X. And Unit X, it's a fascinating read. But one of the chapters it talks about is AI. So it talks about doing bad with AI, doing bad to AI, and doing bad because of AI. And I thought that was a really good way to kind of break things down, at least in terms of the military. And doing bad with AI, an example is like AI-driven weapons or an AI-powered tank. And of course, things can go wrong. And I mean, it can be argued killing or destroying something is never kind of right. But this really took off because of, and the book talks about the Russian invasion of Ukraine. And that was really the world's first drone war. So we're seeing how AI/ML has played a role in that, but also just advanced military methods and drones, how a cheap little drone can take out a really expensive tank, or how a cheap little drone ship can influence huge navies, right? So the book talks about that. And doing bad to AI, for example, fooling AI systems, sensing systems, or corrupting AI vision. Doing bad because of AI, for example, AI and LLM hijacking the gold digger malware and AI, like for example, hijacking bank accounts, that sort of thing. And finally, we're going to talk about some of the AI/ML players. Now, before I talk about this, I just want to set the stage. Early years ago, I had slides where I kind of drew a sort of just a broad landscape of the AI/ML players, and there are countless almost companies in this space, and moreover, lots of companies already doing something have AI/ML departments. It's going to be so pervasive that almost every company has some kind of aspect of AI/ML. So here I'm just listing a few examples, um, uh, maybe some of the slightly bigger examples, and even this is probably needs to be updated as I created it, a while ago. And things are moving very fast in this landscape and in this space, and there are many companies sprouting up overnight, and some will be amazingly promising, and they'll change the world. But of course, the big players are the 700-pound gorillas in the room are also doing lots of stuff with AML. So like Cortana and Deep Blue and Watson and Alexa Voice and Echo and Amazon Machine Learning and Salesforce, Apple, Siri and Perceptio, Emotion, Vocal IQ, Facebook and DeepFace, M and Fair, Google's TensorFlow, Google Now, Google Brain. So I attended a Google talk a little while ago, and they had a pretty good way of thinking about their projects, right? AI for social good, AI for creativity, and AI for language. Uh, note the difference between that and the neat Unit X way of looking at the world, right? Doing bad with AI, doing bad for AI, doing bad because of AI. So Google thinks about it in a more sort of positive way, right? Like, what's the social good I can do with AI? I can uh, disaster manage or manage fires and disasters better, and I can solve world hunger, and I can improve health. Or AI can be a boost to creativity, such as the party application or Funaki. This is amazing, by the way. If you've seen, basically just with a sentence, just with a series of sentences and words, you can create a movie. That's pretty incredible. AI for language. So I've been to 31 countries around the world, as I said in my introduction, and I'm traveling all the time. So and Google Translate is amazing. Google Translate and Google Lens make it so much easier to travel. So this in the past couple of years, I've been to Greece and Japan and South Korea and Paris and France. And I'll be going to Vietnam in 2026. So in Italy in February. So Google Translate, so amazing, so incredible. If you don't have that on your phone, you absolutely have to get it especially if you travel. So all right. So there's lots and lots of other interesting things happening at Microsoft, for example. Their innovation sandbox, business scenario things, AI for society, autonomous systems, security responsibility. I won't go into all these, but lots of interesting applications. And I kind of looked around and searched around. There's so many interesting projects happening now. I'll just highlight a few of them here. So GNOME by Google DeepMind is a tool that can identify new stable materials at low temperatures, which could revolutionize energy, material science, and processing power. There's really, literally, atoms are like building blocks. You can put them together in so many different ways to make molecules and compounds, and using AML to create new materials, I think, is a sort of natural data mining, no pun intended, thing to do. But also AIML has been used for example, to understand protein folding, and that's an important problem in biotechnology. So brain-computer interfaces. So jacking your brain into a computer. We'll see more of that. Graphcast or climate prediction. So predicting the weather is an extremely difficult thing to do, very data intensive, because the weather can be kind of unpredictable, right? It's very probabilistic. So Graphcast, you'll see more of these sorts of applications. Like, notice all these are very data intensive kind of applications. Something that's very good that AML is good at mining data. And of course, we talked about robotaxis and driverless taxis. multilingual transcription. So using AI in terms of language is also a very data intensive, but also a very useful thing, right? It's a low hanging fruit. It's something that AML is good at, processing data and language with like large language models, and applying various different things for language stuff like language transcription and translation are natural next fit for algorithms to explore. Snorkel AI and data labeling. So I mentioned one very manually intensive thing to do is for people to manually label pictures of cats or whatever. And so automating that is interesting. Juganu is a like a digital twin for retail. So it leverages lighting and infrastructure to provide a wireless computer vision and advanced services for connected environment. So this is a kind of like you might think of this like a smart city, right? Like it's an aspect of smart retail or smart city, using lots of sensors, and then drug discovery. So we just saw a thing about figuring out new materials. Well, drugs are just compounds; they're just atoms. They're just collections of atoms in special ways that have some effect on when we ingest them. And trying to discover new drugs is extremely difficult and very hard. Sometimes prone to errors and requires lots of exploration and so that's another big data mining sort of thing that AI is naturally going to be good at. This year, I'm also Bell Labs is one of the locations where I work, and I'm the Bell Labs photographer at work. So I had the pleasure and opportunity to be the photographer for the Bell Labs 100 Centennial event. So this is the 100th year of Bell Labs. But Eric Schmidt, former CEO of Google and former Bell Labs intern, gave a really interesting talk on AML during this event. And he said, people, the hype is real, essentially, in a sense, right? So he said that AML is going to get to a point, it's a race, right? It's where companies and countries are racing against each other, and somebody's going to make it to the finish line first. Somebody's going to actually create an AGI thing first, and it'll only get faster. It'll only get faster after that. It's going to be not just a race, but the person who wins that race, the people who are going to create that AGI first, are going to reap some incredible awards. Eric Schmidt says. So at the Bell Labs event, I've never been in a room with so many Nobel Prize. There were 4 Nobel Prize laureates and 2 the Alan Turing Award is like the Nobel Prize in computers. And just an amazing cast of people just to listen to them. But Yann LeCun, the grandfather of AI, the godfather of deep learning, also talked about man and machine partnerships and the evolution of AI. So also very interesting. If you ever, I don't know, maybe there's some videos you can search online, but it was very interesting to listen to them talk about the future of AI. So in summary, what have we learned? What do I want you to, if you walk away with nothing else, these 2 slides I'm about to show you, I think are what I'd like you to walk away with. So artificial intelligence are programs and machines that learn, they reason, and they make intelligent decisions. We talked about artificial narrow intelligence, and we're kind of on the cusp of artificial general intelligence. The programs that can basically think for themselves and they can do some of the things that we associate with just general intelligence. And we're already sort of in the tendrils of super intelligence, self-aware intelligence and systems that can think and learn and decide on their own. We spent a lot of time talking about machine learning because machine learning is really part and parcel of what AML is today. It's really mostly machine learning, and I think we have maybe to really discover something super unique to what is artificial intelligence, right? And maybe we'll get there. Maybe there'll be so right now we're still more or less work from a von Neumann architecture. There's a processor. We think of something that stores. There's some program. That von Neumann architecture is still essentially with us today. But the human brain doesn't work like that. We don't have a little disk drive in our head. We don't have a central CPU chip. Our brains don't separate cognition from memory. And that's a different way to think about computing in general, right? And maybe AI will do that in the future. Who knows? But right now we're still kind of in that von Neumann architecture, in the 1950s architecture, but we're evolving quickly. We're the neural network way of thinking of things is evolving quite quickly. So machines that learn through experience without explicit programming. We talked about various kinds of learnings: unsupervised, supervised, semi-supervised, and reinforcement learning. Even if you don't remember all those techniques, if you remember at least these 4 categories: unsupervised learning is free form, like playing with Lego blocks; supervised learning that has some sort of target, it has some sort of goal, and it's supervised. It's people telling you this is what your objective is. Semi-supervised learning, kind of a mixture of these unsupervised and supervised learning, and then reinforcement learning, think like carrot and stick. We talked about AI agents and agentic AI. So AI acts that can act autonomously in complex environments, make decisions, and create content without human oversight. It's driven by, its foundations are a set of really advanced protocols, agentic frameworks, and really it's building on these bots. Taking those bots together has created AI agents, and taking multiple agents together is bringing us towards the next steps here in agentic AI that we've seen in 2025 and will continue to see in the upcoming years. And finally, the summary slide that I'd like to leave you with is don't forget how AI/ML works. In general, it's trying to solve some sort of problem, and in machine learning, the better you define that problem, the better it's able to work. It's going to take or train on some kind of raw data, raw input, and that data is is only as good as the ability to solve the problem is only as good as that data. And there's some data pre-processing to clean and format that data before training. And at least presently now, AI/ML needs to train. It needs to, just like a baby walking, or we take walking so much for granted, or vision so much for granted. But we took years to figure that out, right? And so AI/ML similarly needs to go through many iterations, and each iteration is called an epoch. So it goes through many epochs to train. And it can be very expensive depending on the model that you're training, to do that training. From that training, it's looking for features. It has some sort of algorithm. This is some sort of method that it's using. And as a result of the model, it trains and adjusts those weights on the neural nets. And we talked about various kinds of supervision: supervised, unsupervised, and reinforcement learning. And finally, the whole goal of this thing, the whole reason why we're doing this is so that it can make some sort of prediction or decision, and it has to have some way to assess how well it's done. So that's it. I hope you enjoyed this talk, and hope you found it useful. I really only touched the tip of the iceberg on a lot of these things. So I hope this encourages you to explore on your own. There's so many interesting articles and things that are happening, and it's an exciting field to learn about. And I hope you'll spark some interest in the area and explore on your own. Okay. So Becca, you often have some set of questions. I may not be able to answer all the questions, but I'll try.
Well, I think you actually, because of your revisions, did a good job answering stuff this time. So I just have two.
Sure.
The first one is basically, what are you most excited about AI doing in the next couple of years, and what are you most concerned about?
Oh, those are excellent questions. So what am I most excited about AI doing, and what am I most concerned about AI doing? So this year I had I was in a middle school outreach program, and a whole, hundreds of an entire school came up with 10 questions. And one of them was kind of similar to the question you just asked. So let me answer the sort of second one first. And they asked, kind of basically, what are the dangers of not AML, but technology, right? A more broader thing. My answer to that was nuclear weapons. So I think the slide that I have on Unit X, I think is for me the one of the more concerning things for AML, right? That it can be used not just for good, but potentially for bad as well, right? Like, I it would be great if all of us could just we're all humans, right? We could all get along, but that's naive, right? So there are crazy people in the world. There are people that do bad. There are criminals. There are crazy leaders, and they invade other countries, and and that and um, today we have. If you think about a spear, you can hurt one person, right? If you think about a gun, you can hurt with like a machine gun. You can hurt lots of people, right? If you think about a nuclear bomb, you can kill, like in the case of Hiroshima, 70,000 people all at once, right? And with AI, you can potentially affect the world. Now think about that. You
For
could
sure.
an AI or virus, for example, a computer virus can affect almost every person on the planet very quickly, right? That's kind of scary. So I think that's maybe that's why maybe this book Unit X kind of hit a nerve. Like, wow, like, yeah, that's some pretty scary stuff that potentially in the wrong hands AI could be kind of scary. Okay, so maybe that's what I'm a little bit most concerned about. Things like how AI might be used to do bad, like warfare or to commit crimes. Or I mean, think of your bank account as just a number. Like it's just a
Right.
number in a bank. What if something bad happens to that? Um, um, and what am I most excited about for what good we can see of AI? So I had a chance to talk to one of our Bell Labs interns this past summer, and he's actually moving to Japan. Um, and I asked him what's interesting, why, and he's in AML, research. And he said that society has a much more positive outlook on robots and AI than we do. So if you just tune your radar to books and common media and articles and movies, a lot of, yes, American society tends to be very sensational, but a lot of our views are pretty negative on robots and AI and
Yeah,
stuff.
for
It's
sure.
it's we some for some reason, maybe somehow it's baked into our, I don't know, our American DNA, that we have kind of a pessimistic view on robots and AI. And I would say I've watched and read a lot of Japanese articles, and I have Japanime movies and stuff, and they definitely have, I would say, definitely a more positive view, that AI can do good. And
Yeah.
I think if you this by the way, this talk by Google is available online. If you just kind of search for this talk, I thought this was really inspiring, and I like Google's vision of the good that can be done with AI as well. So in the end of the day, those are two excellent questions, Becca. And at the end of the day, AI is a tool. I mean, what can you do with a computer? Can a computer be used? A computer is also just a tool. Can it be used for good? Can it be used for bad? Of course, it can be used for both. And I think having a vision to try to transform society for the good, to help people in disaster situations, and to solve world hunger, and for improving our health. Um, I think I'm excited for the social good that AI can do. I think these things and there's some of the things that I engage too in my research as well. So I think that's what I'm excited for.
Yeah, Japan, by necessity, has been exploring caretaker robots for elderly people. And
Yeah, right.
as you know, disability law is one of my other areas, and
Mm,
there's a lot of really interesting implications
mm.
for improving the life of disabilities if these robots get to a point where they're accessible cost-wise. because then people
Yeah,
can live a more independent life,
sure.
which
Oh,
I think is
absolutely.
critical.
Definitely. Yeah.
Um,
I think that's and as as populations decline and the worker pool shrinks and they have to support an ever graying
yes.
society, and costs of healthcare costs rise. um, I think finding interesting ways to help using AML is also a very interesting area to explore. And also, as people age, we start having problems with hearing and seeing, and so there's lots of areas where AML can step in to help people who are um, handicapped and to see and hear and think better. It's a
All
natural
right.
fit, I think, for exploration. Yeah.
Last one, and then I will let you get back to everything else that you do with your life. So one of the themes of this course is balancing the need for innovation against the need for safety. And that's where the regulatory tension is right now. And as I'm sure you're aware, that's changed. The Biden administration was a little more heavily weighted towards safety, so is the EU. The Trump administration is very heavily weighted towards innovation. So, as someone who uses AI professionally and develops using it, where do you see that innovation versus safety balance?
That's a really interesting question as well. A really excellent question, and and certainly very contemporary, certainly very relevant for our times right now. Um, you might also think of things like the balance between using energy and trying to save energy, or doing
Yes.
global harm to the environment, to running head full speed with our industry. And that's something that I directly play in. So some of my research is directly in that topic. um, in terms of safety versus innovation, there's lots of ways to think about that, I think. And there's it's kind of like asking somebody what's their favorite movie, right?
Right.
There's lots of different areas of technology, right? Like it's not a monolithic thing, right? There's industrial technology, there's retailing technology, technology related to energy, like I think oil reserves, mining oil reserves. So I would say that just about every single area of technology also has safety concerns or potential impacts to safety. Some maybe more than others, maybe. Like for example, a factory can spit out pollution, um, and a factory like I talked about, Industry 4.0, has lots of safety concerns. People are around lots of fast-moving parts, and you can easily lose a finger or arm. And those industries that are more information oriented, like banking, you might get a paper cut on a piece of paper, but it's maybe a little bit harder to kind of quote unquote hurt yourself physically. But you can do a lot of harm digitally, right? So um, I think it's it's a it's an area that I think is really important for our inventors. And I'm an inventor and have multiple patents, and my research is product oriented. So I do a lot of I'm constantly working on ways to create and innovate in the innovation space, right? And particularly in the wireless industry is my industry. And uh, I would say, maybe this is a message to all innovators. If you're an engineer, like such as me, and you're innovating, I'm super fortunate. I love my job, and I'm super fortunate to be in the position that I am, to be able to do actual innovation, right? To be able to not just like develop product and like on an assembly line, but to actually innovate. So if you're an innovator, I think. Uh, Security and the greater impact to society and the welfare of society and the impact you might have in society is something that should be on the top of your mind. Like creating not just for social good, but to avoid social harm, I think is important to balance. And I don't know that uh, there's engineering is all about trade-offs, right? So we're always constantly trading off cost against safety, against against production feasibility, and there's unlike science, or math, there's one single equation, there's one single answer, there's just a single theory that is right. There's something that's right. In engineering, there's lots of ways to do something. There's multiple solutions that are possible. Do you want a Rolls-Royce solution that's just a lot more expensive but spot on perfect? Or can you tolerate a moped, like something that's a lot cheaper, will still get you there. Maybe it'll take a little longer, but it's a lot cheaper, right? So there's lots and lots of trade-offs we often make. And some of them are obvious and some of them are not so obvious. And certainly safety is one of those that are, so I will say, for example, there are 11 major drivers in 6G. And one of them is sustainability. One of them is how do we now develop this? We have wireless is everywhere. It's ubiquitous. How do you make it more sustainable? How do we make it so we're not doing so much damage and we're making the planet safer for our next generation of humans? And that's going to be more baked into the DNA of 6G, right? It wasn't in 1G, 2G, 3G, 4G, 5G. But it's on everybody's thoughts who's working on 6G. So I guess it's a great question. It doesn't have a simple answer, and maybe some of the best questions are thoughtful ones that keep making you think long after you've asked the question. But I certainly try to keep that on the top of my mind, and I think there isn't necessarily a right answer to that.
Right.
Should we just stop inventing just for the sake of safety? Probably not. Should we just invent without any thought to safety? Definitely not, right? So there's probably some kind of balance in the middle there that's the right answer.
All right. Well, thank you so much for your time. I know my students appreciate it also. And let's talk soon.
Yes, thanks so much for having me, and I really enjoyed this, and to look forward to good luck to all the students. Good luck, and I'm sure you're in good hands with Professor Becka. Okay, thanks a lot.
Thanks. Bye.